All right, this is Unit 1, Topic 6. And the lesson topic is absolute value inequalities. So we've seen absolute value equations, and we talked about how you could have these positives or negatives coming from the inside. And so when we do that, we always have these two cases that we set up for our absolute value equations. We're still going to have two cases that we need to set up for absolute value inequalities. So let's look at our two different scenarios. We have one scenario where we have an absolute value with a greater than or equal to. It works the same way. And then our second scenario, we have an absolute value and a less than or equal to. So let me walk you through what that means. So this one, our value on the inside, the absolute value has to be at least 7. So let me show you what that looks like on a graph. So at least 7 units away would put us here. And then if we want to be at least 7 units away from 0, that would take us off in this direction. Okay, so 7, 8, 9, all of those would make this true. Okay, so that would be, you've got x is greater than or equal to 7. That's what this little portion is right here. However, remember, it could also be negative. So -7 also has an absolute value that's equal to 7. And then if you want the absolute value to be more than 7, that would actually take you in this direction. -8, -9, -10, those would all make this true as well. Like if you popped a -9 in there, the absolute value is 9, which is greater than or equal to 7. So this one right here is x is less than or equal to -7. And the way this graph looks, if you remember from the previous lesson, that is an OR graph. So one or the other. Interval notation would look like this. The arrow on the left means -infinity up to a -7 with a bracket because of the closed circle. And then remember with the OR graphs, we put that little union symbol. This next one picks up at +7 with a bracket, goes off to the right forever, which is infinity. So that's the first scenario, when you have a greater than, or it works the exact same if it's a greater than or equal to. Let's look at the next one. So here, our distance has to be less than 4 units from the center. So here's the center. We go 4 units in this direction, or we can go 4 units in this direction. Because remember, absolute value can be positive or negative, but I can't stray any farther than that. So my distance has to be within 4 units, so that traps us in between these two values. If I go past these numbers, I've gone too far. My absolute value would be more than 4, and I need it to be less than 4. So this is a less than, which looks just like the and graphs that we were doing the other day. Okay, so this, if we put it into those like little inequalities like this, we have this piece right here, which is x is less than or equal to a +4, and then we recognize that it looks like an and graph, and this piece says x is greater than or equal to a -4. And last little detail we want to write down is our interval notation. Remember, no arrows, so no infinity. It just starts at -4, ends at +4, and we would put brackets on both ends. So that's kind of a quick little introduction to what the absolute value inequalities will look like. So this next box, it says, so what does this mean? What this means is that absolute value inequalities are compound inequalities. They're either and or they're or, so they turn into these compound inequalities like we worked with in the last lesson. Okay, so we have these steps. I'm going to pick a number to start with. We're going to start with number 1, and I'm going to walk you through these steps that we're dealing with right here. Okay, so step 1, isolate the absolute value expression. Notice right here it already is isolated. When we say isolate, we want this to be the only thing on the left-hand side, which it is. Number 2, create 2 cases. So here's a little acronym for you. KISS stands for keep it, switch, switch. Okay, so step 1 looks like this. First, we keep everything that you see exactly the same. Okay, so you take the inside, keep this exactly the same. And then the second scenario is that you take the inside, and then you take these 2 pieces and you switch switch. That's what the switch means, is the greater than switches to a less than, the 7 switches to a -7. And then right in the middle, we should have a word. That word is either or and. If you start with a greater than, like we do here, that word is or. Okay, so that's step 2, is to create your two cases. That's the hardest part. Step 3, you solve both inequalities. So here I'm going to subtract 6 from both sides. So 7 minus 6 is 1. Here I'm going to subtract 6 from both sides. -7 minus 6 is -13. So those are your two pieces. Remember, the OR graph means I just plot them on the same number line. So greater than 1, here's 1, open circle, greater than goes off to the right. Less than -13, here's -13 all the way down here, open circle, less than goes to the left. So our interval notation should look something like this. Two separate pieces with the infinities on both ends. So here, the left arrow starts with -infinity, and it gets up to a -13, which is not included. Little union symbol to join two sets together. This next set starts with a 1, which is not included, and the right arrow goes off to infinity. So that's the first type, when you have a greater than. So that's kind of following through our step-by-step with number 1. Let's also do number 4. So step 1, isolate. It already is. There's nothing on that left-hand side. Create two cases. So you take the stuff that's on the inside. First, you keep it. Second scenario, we take these two components and we switch. Okay, so that's what the keep it, switch means. Notice this part from the inside is not changing. Then we need a word in between. This less than fits with this set. And so if we turn it into a compound inequality, that's going to be an and. So set it up and then solve. So here I'm going to start by subtracting 7 from both sides. So 27 minus 7 is 20. And then divide both sides by a -4. So I'm dividing by a negative, so I'm flipping my symbol. 20 divided by a -4 is a -5. So it's my first part. Not going to plot anything yet. I'm going to solve this one first. So here, subtract 7 from both sides, so I get a -4n is greater than or equal to, and then I have a -27, and I'm subtracting 7. So that leaves me with a -34. So divide both sides by a -4. I am flipping that symbol again. -34 divided by -4. A decimal is probably easiest. This ends up being 8.5. All right, so and means in between. Bigger than -5 would start us at -5 and then go off in this direction. Less than or equal to 8.5. So just kind of sneak that between 8 and 9. That goes off in this direction. So remember, these ones just kind of meet in the middle. So interval notation starts on the left at -5, which is included. Ends on the right at 8.5, which is also included. All right, so those are kind of the general setups. I'm going to keep flipping back to this page so you guys can see with our other examples that we do. So next one I want to show you is number 6. So step 1 we have to do for the first time here. We have to isolate the absolute value, which means I'm subtracting this 3 to make sure that this is by itself. So isolate this by subtracting 3. So 25 minus 3 looks like this. So now I set up my two cases. So I have the 8a plus 10. So first I take this stuff and I keep it. Then again, start with the 8a plus 10. Now I take this stuff and I switch. So those are my two scenarios which I need to solve. I'm going to start by subtracting 10 from both sides. And then my second step will be to divide both sides by 8. So again, decimal form if you prefer. 12 divided by 8 is 1.5. This one thing I missed here, this started out as a less than. Less than means and. So this is going to be one of those that has the overlap. Now solve this one. Subtract 10 from both sides. -22 minus 10 is a -32. Divide both sides by 8. -32 divided by 8 is a -4. So this and this, we want the overlap. So start with 1.5. So that is halfway between here. And less than takes you to the lefts. Greater than -4. Starts right here with an open circle. Takes you to the right. And remember, these are the overlaps. They kind of meet in the middle. So the interval notation is just in between two regular numbers, no infinity. So on the left, we start with a -4, which is not included. On the right, we end with 1.5, which is not included. So we saw one where we had to isolate the absolute value. Let's look at another one, number 10, where it gets a little more complicated to isolate the absolute value. So first thing you do, you've got a number attached, which is multiplied, and then you have this other floating number. So we start by adding that 1 to both sides. So I'm going to add 1. So on the left, add 1 to a -21. I get a -20. Then this -4 is attached, so I have to divide, since right now it's being multiplied. So divide both sides by a -4. I'm dividing by a negative, so I am flipping this symbol, and -20 divided by -4 is 5. So step 1 is complete. I can't set up my two cases until this absolute value is isolated. So now I can set them up. So take the inside. First you keep it. And this is a greater than, so I use the word or. Case 2, take the inside and you switch, switch. So this one, just a quick one step. Here I'm going to subtract 9 from both sides. So 5 minus 9. This one I'm also going to subtract 9 from both sides. So -5 minus 9. So this is an or. That means you just put it all on the same number line, make it one big solution. So greater than or equal to a -4. That means close circle on the -4, and I go off to the right. Or less than or equal to -14. It's a closed circle on the -14 and go off to the left. All right, so interval notation on this one. This first set starts with a left arrow, which is -infinity, never included. Ends with a -14, which has a bracket because the closed circle shows that it is included. Then the little union symbol means you're joining two sets together into one. This next set starts on the left with a -4, which is included, and goes off to the right. Infinity is never included. So that's number 10. We're going to finish off with one more. Let's do this bottom one down here, number 12. So again, step 1, isolate that absolute value. So I have a number attached, which means it's multiplied, and then I have this separate number. So I'm going to start with that. So add 9 to both sides. So add 9 to the left, and it cancels. Less than, add 9 to the right. 75 plus 9 is 84. Second step, like I said, this 4 is attached, which means it's multiplied. So I'm going to divide. So divide the left by 4, and we get just the absolute value, which is what we needed. Right-hand side, divide that by 4, and I get 21. Okay, so now it's isolated. Now I can set up my two cases. So case number 1, take the stuff on the inside. These two things, just keep it. And this was a less than, so it's going to be an and. Case number 2, take the 9 minus 3n and switch, switch. So this switches to a greater than. This switches to a -21. So let's solve each one. This is going to be an and, so it's one of those overlap ones. So here I'm going to start by subtracting 9. So 21 minus 9 leaves me with 12. And then divide by -3. So I'm dividing by a negative. I have to flip my symbol. 12 divided by a -3 is a -4. So I'm going to graph that and the overlap with whatever this turns out to be. Here, subtract 9 as well, so -21 minus 9 is a -30, and finish by dividing that -3. So I'm dividing by a negative, I am flipping my sign. -30 divided by -3 is 10. So this will be the and, the overlap, so greater than a -4. Here's the -4, and that goes off to the right. And less than 10, here's the 10, going off to the left. Remember, these ones are the overlap, so it just ends up being that little piece in the middle. So last little thing is my interval notation. No infinities, because there are no arrows. It's just in between these two numbers. So the set starts at -4, which is not included, because it has an open circle. And the set ends at 10, which is also not included. All right, that is lesson 6.